Welcome to this first of 4 lecture videos for the 01_lecture notebook. If you do not yet have this notebook, you can find it by using the Open Notebook option within Colab, which also appears as this pop-up window when you first go to Colab. And you can search for CU-Denver-Math Stats-OER as the organization to search for repos within the GitHub option. When you search for that organization, you will then want to select the Programming for Data Science repo, and you will find the 01_lecture notebook there. For more details on how to save a copy and organize your files on Google Drive, please watch the first video in this YouTube playlist, which I will also link to in the description of this current video on YouTube. Before we discuss the learning objectives for this notebook, it is important to emphasize the goals for these lecture videos and discuss what this course is exactly in order for you to properly set your expectations for the course in terms of both the content you will learn and the time commitment you should plan on making. As for the lecture videos, there are several goals. First, they are meant to be comprehensive in terms of covering the content presented in the notebooks. Second, they are meant to offer additional insights by discussing and emphasizing certain results. They are also meant to encourage you to explore and experiment with materials beyond what is simply presented. This is intended to help you develop your independent learning skills. Finally, they are meant to add clarity and help you avoid unnecessary confusion when encountering certain topics for the first time. Even though I will not read over all the content verbatim as it appears in the notebook, after all, this isn't exactly story time with Dr. Butler, I will read over certain portions carefully and offer some supplemental commentary to help us achieve our goals. As to what this course is and what your expectations should be in terms of the difficulty and the workload, well, this is a rather involved answer. You should read the beginning section of this notebook, which is found at the very top, which I'll summarize here. So what is this course exactly? Well, the question does not have an altogether obvious answer. This is a 1000 level course, which means it is an introductory course. However, it is also a course that involves learning a programming language, specifically Python. Learning a programming language is a lot like learning a foreign language, except that the rules of diction and syntax are incredibly strict. It is therefore quite common to view introductory programming courses as objectively difficult by 1000 level course standards. And this is not just any programming course, this is a programming course for data science. You may have a fuzzy notion of what data science actually is, but thankfully Wikipedia has a reasonable description of data science as an interdisciplinary field that uses techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, domain knowledge, and information science. In this context, it is certainly fair to view this as a programming class that exists at the intersection of mathematics, statistics, and computer science. Along the way, we will learn how to solve some common computational mathematics and statistics problems. These are found in modules 04 and 06 of this course. We will also see how to scrape data from the web to analyze and interpret results in the context of data storytelling. This is found in both modules 05 and 06. We will dip our toes ever so slightly into the realm of machine learning algorithms based on classifiers and artificial neurons. This is in module 6. In other words, this is not your typical 1000 level course. Now, this is not to say that this material is inaccessible at the 1000 level. It just means that we cover a lot of ground over the course of the semester. It also means you need to calibrate your expectations with respect to workload. You should expect to work at a minimum 9 to 12 hours a week in a typical 16-week course format. This is doubled during an 8-week summer format. How you schedule time for the course materials is something that's up to you, but I recommend devoting at least 2 to 3 hour time blocks with no distractions spread out over multiple days so that you can chunk out the pieces of the material that you're going through. This is something that's really important, is how you schedule your life. You shouldn't be expecting to do all the 9 to 12 hours at once, and you shouldn't be expecting to work 5 hours a day. You should be expecting to work consistently on this material every day for a few hours. You should also understand and really absorb the following tenet of computational data science. You must become comfortable operating with an incomplete understanding of the problem. This is accomplished by identifying the portions of a problem that are necessary to understand in order to solve it correctly from the portions of a problem that simply allow you to solve it more elegantly. Now, we are not necessarily after elegant solutions in this course. This is very important. Now, this is not to say that you should not pursue as elegant a solution as you can. It is simply to say that we are focused on developing the following things. In Module 01 through 03 of this course, we are going to develop your basic Jupyter and Python programming skills. Basic problem-solving skills that require modifying and applying existing code are shown in Modules 04 and 06 that involve higher-level concepts. So we're somewhat managing the cognitive load here. As we're developing our programming skills in Module 01 and 06, you'll be asked to dive deeper and go beyond what is simply shown in the lecture videos in your external activities and homework assignments, which we'll discuss in another video. As we start to move on to actually more complicated mathematical topics and more sophisticated programming concepts, I'll be providing most of the working code for you and ask you to think how to apply that working code to various problems, and also what individual lines of code are doing and how to modify it in order to have it do different functionalities in different circumstances. Along the way, you are certainly likely to find that you are pushed out of your comfort zone on any number of occasions. But remember the tenet, and you will start to develop comfort and confidence in being uncomfortable with an imperfect understanding of material. At the very least, you should find that such feelings of discomfort and lack of a complete understanding to be a more familiar setting and less threatening. It certainly helps to realize that no one, certainly not me, knows everything, and you are not expected to be perfect at anything. And to help guide you along the way, the course will use all this interactive content in Jupyter Notebooks, along with these lecture videos to help parse out ideas as carefully as we can. Additionally, you will often have the large portions of code presented to you in their entirety, as I previously mentioned. Now, I'm going to stop reading this stuff here. You should continue to read the rest and maybe read this over for yourself at your own pace. But that's all I want to say in terms of what this course is about and the level of difficulty of this course. It's something you should consider. If you don't have the time to devote to the class and the materials now, it's best to take the course at a time when you do have that available time to devote to the materials. Now that we have discussed what this course is about, we will now turn to the learning objectives for this notebook. The learning objectives are to understand the notebook environment and how notebooks are used in this course. We want to understand the difference between code and markdown cells, which are also referred to as text cells in Google Colab. We want to create and execute code cells and understand how the order of execution impacts results. And we also want to create markdown cells with some stylized text formats, much like I'm showing here. To help you navigate course contents, the beginning of every notebook contains an itemized list of notebook contents related to the big picture takeaways, as well as specific embedded activities that count towards your grade. And by the way, I provide solution videos for these activities, often as non-embedded videos that you can easily find on Canvas or by looking at my lecture playlist for this course on YouTube. You can also view a more detailed table of contents at any time. This is found over on the top of the left panel of the notebook over here. When you click on that icon with the 3 dots and the 3 lines, a table of contents opens for the notebook, and you will be able to see a far more detailed list that allows you to easily navigate the contents. You can click on anything at any time to immediately jump to those contents in the notebook, and then just navigate back to where you previously were. So what are Jupyter Notebooks and Markdown cells? Well, a Jupyter Notebook effectively turns your computing device into a computational laboratory where experiments, let's call them scientific computations, are not only reproducible, but understandable and explainable as well. You should think of a notebook as a living document made up of individual cells that respond to how you choose to interact with them. If you left-click on a piece of text, just once initially. So as I've done here, you should see how the border of the cell is shadowed, indicating that a cell is selected but not being edited. We'll discuss how to edit cells in just a bit. A notebook is composed of a sequence of different kinds of cells. The two most important types are Markdown, and there are Markdown guides you can find from Colab, and also cheat sheets that you can find in Bookmark online for how to do some Markdown formatting within text cells. That's what Google calls a Markdown cell, is a text cell. And then there's code cells that contain code to be executed by a particular piece of software, which we refer to as the kernel. And in Google Colab, they'll often refer to that as the runtime. We'll start working with code cells in a little bit. In a traditional Jupyter Notebook or Jupyter Lab environment, so not in Colab, there are also cells called raw cells that are good for displaying code that does not run, but we will hardly, if ever, use these, even when we're in those traditional environments. We certainly don't use them in Google Colab. Google Colab also allows you to insert scratch code cells where you can test out or investigate some small pieces of code before putting them in code cells. We will not typically use those in this course, but they are at times convenient, and I will show them later in the context of evaluating code cells. When a Markdown cell is in edit mode, it will appear much differently. To enter this mode for a Markdown cell, you simply need to double click on this cell. So for instance, in this cell right now, I'm in a display mode, but if I double click on it, you'll notice that I enter in to an edit mode. And what you see is the formatting that I've done on the left and how it appears on the right. This is the wonderful thing about notebooks. If you're ever curious how someone got text to look however it does, you can simply double click on the cell containing that text and you will see how it appears on the left, or excuse me, how it was formatted on the left and how it appears on the right. Now, this is something that's a little unique to Colab. In a traditional notebook or Jupyter Lab environment, you would just see this type of rendering if you double click the cell, and you'd have to run the cell in order to see how it will appear. This is a really nice feature in Colab though. So one of the things you see is, for instance, like how did I make strike through text over here? Well, that was with using some tildes. How did I make bold font? Well, that was with 2 asterisks on either side of the text. What about italicized font? Well, that is coming from just using a single asterisk. And then you can say, what if I used 3 asterisks? Well, then you'll see, if I do it on either side of the text, that it makes it bold and italicized. And then the bullet list that you're seeing, an embedded bullet list, I'm doing that with hyphens or dashes, however you want to call those. And by indenting them, I create the sublists. So that's something that immediately you see how all this stuff is done. You even see how I made the word cheat sheet a link to a Markdown cheat sheet. I just put the word in square brackets, and then next to that word, in parentheses, I actually put the URL, and then I also added this Markdown cheat sheet in quotes. And so you'll notice if I hover my cursor over the word cheat sheet, then it will say Markdown cheat sheet. So it gives some visible rendering of what the link is about. So that's about how you edit. You just enter in. And then the way I exited was I pressed Shift and Enter on my keyboard. Similarly, another way to exit the edit mode is I can just click anywhere else that's not in that, that cell, and it will leave it and render the Markdown cell content. So that's something you should go ahead and try now. You could pause this video if you're following along with the notebook and do this for yourself. And then I again describe how you can exit the editing mode. And I also describe what's going on in a more traditional environment as well, but we're going to skip that in this video. Now here's an example of a code cell. This is an example of a code comment because it starts with what I would often call it the pound sign, but I think most people now call it the hash symbol. But if you see that symbol, that's a code comment. This is a code comment that's taking up an entire line of code, and comments can also be to the right sign of a working piece of code. And the typical formatting is to put 2 spaces, then the comment, the symbol for the comment, and then the comment. That's a typical formatting for an inline comment, but you might have other parts of the code that have lots of comments that take up multiple lines, and then they won't be to the left of any working code. So if I execute this piece of code, one of the ways I can do that is I can press Control Enter to execute and not move on to the next cell. I can press Shift Enter to execute and move on to the next code cell. I can click this button right here, or you can also go to this runtime option and also select to run all sorts of cells like at once. So there's lots of ways for you to execute these cells. I am going to do it by pressing Shift Enter initially. So you'll notice that executed the code cell. It gave the output, which is what 17 times 235 is, which is 3,995, and it moved on. See, my cursor is in the next code cell. And I also want to point out, move here, notice the number 1 that's showing up in the upper left corner of the code cell in square brackets. That's telling me this is the first code cell to execute inside of my Jupyter Notebook in Colab. If I execute this next code cell, you'll see that I put that hash symbol to the left of this command, 17 times 235. It did not have that comment symbol to the left of it. Now it does. And if I run this, now I'll press Control Enter and watch where my cursor goes. It doesn't move. So it executed, but it didn't move me to the next cell. If I had pressed Shift Enter, notice how it selects the next cell. So Control Enter will run but keep you in the same cell. Sometimes you want to re-execute a code cell many times, so that's a useful thing to know. But notice that no output is generated. This is because, in fact, this operation was never run. It was considered a code comment, not an actual operation that the Python kernel, was supposed to execute. So if you ever have pieces of code that you think might be problematic or you're troubleshooting, commenting out certain parts of code is very useful for perhaps locating where issues in the code may be. So that's something that's worth knowing. Another useful cell that you can insert is a scratch code cell. By inserting a scratch code cell, you can execute various lines of code that you can be testing before you put them into the actual contents of your notebook. So suppose that I was just playing with different numbers and I saw 17 times 235 was 3,995, and it just occurred to me, well, I want to know what 23 times 4,398 is, but I don't want that in my notebook. I'm just curious at this moment. Well, I can insert a scratch cell. I can run this and see and go, oh, it's 101,154, which I want to know for some random reason. But the point is, you can play with code and test things out and ideas that you might have for inserting into the notebook without having to worry about changing the notebook contents until you're sure that the code is going to produce what you want. That's a good use of a scratch code cell. To close it, you just simply click that X and it goes away. We end this by discussing how to create, delete, move cells, and also add comments to cells. So to create a cell, there's several ways you can do this. First of all, you'll notice that there's this code and text option with plus signs next to them near the top of the notebook. If you select either of these, and you will insert a code or a text cell below what cell you currently have selected. Similarly, if you hover your cursor between two cells, the plus code or plus text options appear as well, and that allows you to put a code or a text cell in a very specific place where your cursor is. Alternatively, if you have a markdown cell selected but it's not in edit mode, or you have a code cell selected but it's not in edit mode, and the way you can do that is, notice my cursor is flashing right here. If I press the escape key, all of a sudden I'm not in edit mode. I can be typing all the stuff that I want. I just started hitting some keys on my keyboard there, and nothing changed in the code cell. It's not in edit mode. Now, if I press the A key, A, that creates a cell above. And notice the default there is that it's a code cell. If I press escape again, and now let's say I press the B key, it creates a code cell below what I just had. And you can say, does it also produce a code cell if you're in a markdown cell? Well, let's see. Let's select this markdown cell here. And if I press B, you'll see that yes, the default is a code cell. And you can change the types, but we won't really get into that here. I would say if you want to insert markdown cells, just go ahead and use this button. I think it's a little easier to do that, to add a text cell. But you might also say, I want to reorder my cells, or I want to delete some. Maybe I created some that I don't have any use for anymore, like these three that I have right here. So you simply just can go over and select this little trash can icon on a given cell, and it will delete those cells. So I'm just zooming in so that you can see, and now I'm deleting those cells. To reorder my cells, I can use these arrows to move a cell up or down. And to add comments to cells, which is particularly useful when communicating with me or seeing the feedback I'm giving you on your notebooks, you can use this little, what looks almost like a little chat box. It's to add a comment to a code cell. And if you click on it, you'll notice that this is 3:27 today when I'm making this video, that I'll use this to write comments about the things you're doing in your code cells, but you could use it to communicate questions to me or respond to feedback that I have if we're passing notebooks back and forth as we're working on things together. And so it's very simple. It's just, this is an example of a comment. And when you actually select comment, now it's there. You can see it's here. And then if we have a set of comments that are going back and forth or questions, you can say that you've marked it as resolved, and it will just clear that comment away. All right. But if it's not resolved, then you should really leave it open. For instance, if it's something that I should look back on, I'm going to look to see if those comments are there. So if you hit resolve, it's like deleting the comment. So just keep that in mind. So that's it.